So today we're going to look at this exponential rule where we take a power and raise it to another power. And this is called power of a power or power of a product rule. And basically it says this, where if I were to have a squared to the third power, that's a squared 3 times. And a squared, as we know, is a times a. So here we'd have a times a times a times a times a times a. Well, what happens is we count up all the a's we have together, and that's 6 a's. So rather than doing that, what I do is I take what I know my exponents are, and I multiply them together. So that's where we get the rule of m times n, or in this case, it would be 2 times 3. Now, the same is true when we have multiple exponents in a parenthesis. Really what happens is it gets distributed to both sets of exponents. So here we would take the m and multiply it by the p and the n and multiply it by the p. Same thing applies when we have just a 1x or a 1y. So here what you're going to basically do is power of a power is to multiply the two together. Alright, so let's look at one to give us kind of an idea. So here we have negative 3m to the third. So we know that negative 3m to the third means negative 3m 3 times, again because that's to the third power. Now I could do this one of two ways. I could write it all out like this and then multiply what I know together. Negative 3 times negative 3 times negative 3 would be a negative 27. And then I also multiply my m's. M times m times m gives me 3, so that'd be m to the third. This would be the final answer. The other way to do it using the exponential rule is to take this exponent here and distribute it to both sets of parentheses, or both things in the parentheses, I should say. So really I could write this as negative 3 to the third power as well as m to the third power. When I do that, I'd always take my number, negative 3 to the third, and again, negative 3 times negative 3 times negative 3 is still negative 27. But here, m to the third, I know that it's going to be 3, because that's what I got from my other answer, but understand that this here is a m to the first, and what I could do is take and multiply these exponents together. 1 times 3 gives me 3. So that's where, again, that m to the third comes in by multiplying the power to a power. Alright, let's try this one using that product of a power rule. So here we have b to the third, y to the fourth, all to the fifth power. So again, I could break this down into two parts, b to the third to the fifth power, and then y to the fourth to the fifth power. And again, when I do that, what happens is I'm going to take and multiply my exponents together. So here I'd end up with b to the 15th power, because 3 times 5 is 15. And then here for my y's, I'd take and multiply 4 times 5, which would give me 20. So the final answer here would be b to the 15th, y to the 20th. Alright, let's try this one where you have several pieces going on here. So notice in this first parenthesis here, we're going to take it to the second power. In the second parenthesis, we're going to take to the third power. So let's start by breaking down that first parenthesis. I am going to break it down into each part. So that would be 3 to the second, s to the third to the second power, and then v to the fifth to the second power. And again, I'm going to combine those in just a second. Let's break down the second parenthesis too. So that's negative 4 to the third power, s to the third power, and then v to the third power. Alright, so what we're going to have here, we're going to combine all the things that we can. Let's start with the first. So 3 squared in this first part here is going to give me 9. And remember again, the exponential rule here is we're going to take and multiply these exponents together. So that's going to give me s to the 6th, because 3 times 2 is 6. And then v to the 10th, because 5 times 2 is going to give me 10. I'm going to do the same thing over here. We have negative 4 to the third power. That'd be negative 4 3 times. That would give me a negative 64. And then I have s. Remember, this is again technically to the first power. So just like I did before, the exponential rule is to take and multiply these together. So here that would end up with s, and 1 times 3 would give me 3. And then v to the third, that would give me v to the 9th. Now, I'm still combining what I have here, and because we're multiplying everything together, this goes back to combining like terms by adding them together. It's not raised to a power anymore, it's just combining what we have. We're still going to take and multiply our numbers together. That's 9 times negative 64. That would give me negative 576. And then again, we're going to combine what we can with our terms. So here's s to the 6th and times s to the 3rd. And this part is where I add my exponents together. So 6 plus 3 would give me 9. And then we're going to combine our v's as well. So that would give me v, again combined by adding 10 plus 9 would give me 19. So the final answer here, once I've simplified it all the way out, would be negative 576 s to the 9th, v to the 19th. All right, let's try one more where we've got some powers of a power. So here, notice that I do have parentheses. PEMDAS always says take care of parentheses and exponents first. And I also have this 5x that's outside the parenthesis. I'm going to get to that in just a second, but I want to make sure that I distribute my parentheses first, take care of that. So here we have 2x squared to the 3rd power. And again, I would get rid of that. I can distribute that 3, that power of 3, to both parts of this. So let's start there. So this would be technically 2 to the 3rd power and then x squared to the 3rd power. So that when I combine them, I'm going to drop down that 5x again in front, and I'll get to that in just a second. But we have 2 to the 3rd power. That would give me an 8. And then x squared to the 3rd power, remember this is where we combine these terms by multiplying. So x squared to the 3rd power would give me x to the 6th. So from here, what you're going to see is I have just a 5x, and this is to the 1st power technically, times 8x, or x to the 6th. So this is back to just combining as we can by adding our exponents together. We're still going to multiply our numbers. 5 times 8 would give me 40. And then here we add our exponents again. So x to the 1st times x to the 6th gives me a total of 7 x's altogether. So 40 x to the 7th would be the final answer here. So hopefully that gives you an idea of how to use product of a power. We'll look more in depth and practice more in class. Be sure to ask questions, and I'll see you next time.